13F and G is a new way of solving systems using matrices. And we're going to use things called elementary row operations. And those operations are these three things. Remember, when we set up a matrix equation, we have two rows. The first row represents the first equation, say 3x plus 5y equals 9. The second row would represent the second equation, negative 3x minus 8y equals 7. And it doesn't matter which equation we write first, so it doesn't matter if we interchange the rows. Also, we can change any row in the matrix into a non-zero multiple of itself. I'm allowed to multiply this whole equation by, say, 2. And then I could rewrite the system as a new system of equations. That doesn't change the value of the outcome. Or I could replace a row by itself plus a multiple of another row. So we use this when we do like elimination. If I want to multiply, if I multiply the bottom one by 5, the top one by 8, I'm replacing these new rows, but then I add them together. I end up with, it would be whatever we get when we add those x terms up. We'll have something x equals a number. That's a new equation that we achieved by adding a row to a multiple of itself. And when we set these matrices up, we want a 1 in the top left corner of the matrix. So let's look at what we're talking about. First thing we want to do is set this matrix equation up as an augmented matrix. In other words, we want it all in one matrix, and what we're going to do is we're going to give ourselves a vertical line, and over here on the right hand side is where our constants go. And I want a 1 in the top left column, so I'm going to start with the second equation. I'm going to interchange these rows right away. Now what I'm going to do with this is I'm going to use row reduction to get into echelon form. For a 2 by 2, what echelon form is, it would have a number here, a number here. It would have numbers in all those spots and a 0 right here. We want a triangle on the top half of this matrix. If we're talking about a 3-variable system, this is what it would look like. Again, we have this upper triangle. That's what we're talking about when we get into echelon form. So for this 2 by 2 that we have, or this 2 by 3, I guess it would be in augmented form, I need to get this 2 to become a 0. And what I'm going to do is I'm going to replace row 2. If this were a normal system that we were going to solve algebraically, we would multiply this one by negative 2 and then add them together, and the x's would cancel. So what I'm going to do is I'm going to replace row 2 with negative 2 times row 1 plus row 2. And what I get with those coefficients now is the first row becomes negative 2, negative 3, 34. Second row stays the same. It would be negative 34. Those first numbers cancel. This should be negative 6. It's important to multiply the whole row by negative 2. So I have negative 5 and negative 35. So my new augmented matrix is 1, negative 3, 17. I haven't done anything to the first row, but I've replaced the second row now with 0, negative 5, negative 35. This negative 5 is the coefficient of y. So now I can set up and say negative 5y equals negative 35. Y is equal to 7. And then I can go to the first row and say, okay, if y is 7, that means 1x minus 3 times 7, that has to equal 17. So x equals 38. Once we get into echelon form, we just work backwards up through the rows. Find the solutions. And there's a typo here. There should be 4x. So again, we're going to do this the same way. We're going to use row operations to get into echelon form. And I'm going to switch the order once again. 1, 3, 5, 4, 12, k. And just like in the previous problem, I want to get 4 all by itself. So we want to replace row 2 with negative 4 times row 1 plus row 2. And to just do a little scratch work over here, negative 4, negative 12, negative 20. Then here's my original row. So this is negative 4 times row 1 plus row 2. And we end up with 0, 0, k minus 20. So in this one, there is no coefficient for x and y. Essentially, the second row says 0x plus 0y equals k minus 20. And if I plug in any number besides 20, if I plug in 5, we'd have 0x plus 0y equals negative 15, and that's not possible. So there is no solution if k equals anything besides 20. And if k is 20, then there are infinite solutions. Because we'd end up having 0x plus 0y equals 0, and that's always true. If k is 20, these two equations are coinciding lines. So they are the same line, there's infinite solutions. And what we do is we give our answer in parametric form. So what we're going to do is we're going to say that y equals t. T is going to be some number in the reals. So if we pick a number for y, then x is going to equal 5 minus 3y. Sorry, not 3y, 3t now. All I'm doing is I'm taking this right here and rearranging it. And saying that whatever this t value is I get for y, the x coordinate of that point will be 5 take away 3t. So if I say that t equals 1, so y equals 1, that would mean that x is 2. And there's specific points that would be solutions, but there just happen to be infinitely many of them. And this stuff in green is what we call the parametric form for our solutions. So here's a 3 by 3. We want the top left to be 1, so we don't have to flop any rows. Now, there are 3 values here that I need to get rid of and turn into 0 using these row operations. But I'm going to focus on the ones in the x column first. So my first task is to replace row 2 So if I want this 2 and this 1 to cancel when I add these together, I need to take negative 2 times row 1 and add it to row 2. And so my chicken scratch work here would be negative 2, negative 6, 2, 30, 2, 1, 1, 7, 0, negative 5, 3, 23. So my second row has become 0, negative 5, 3, 23. And then I'm also going to take and replace row 3. If I want row 3 to disappear, what times row 1 plus what times row 2 will make that happen? We could do negative 1 times row 1 and 1 times row 2. So we have negative 1, negative 3, 1, negative 15, now we have one more value that needs to go away. We still need this 2 to become a 0. So now I'm going to look at row 2 and row 3 and get rid of one of those new values. So now I'm going to replace row 3 with a multiple of row 2 plus a multiple of row 3. And here we're going to have to use multiples of both of these. I just realized I made a mistake back here. There shouldn't be a 2. There should be negative 4. So now we can continue on our way. And we want to replace row 3 with something times row 2 plus something times row 3. And this we're going to need two values, a multiple of each one of these, because I want the negative 5 and the 4 to be my canceling out when I do elimination. So maybe the top times negative 4 and the bottom by 5. So time for my scratch work, 20, negative 12, 23 times 5, sorry, 23 times 4, negative. We'd have negative 92. And then 5 times the last row, and I think I made another mistake here. I think this should be negative 23. Go back and check that, but I'm pretty sure that should be a negative 23 in there. But now when I add, I get negative 17 and 17. So my new augmented matrix is 1, 3, negative 1, 15, 0, negative 5, 3, negative 23, and 0, 0, negative 17, 17. And what we can now do is work backwards. Negative 17, z equals 17. That means z is negative 1. And negative 5, y plus negative 3 equals negative 23. Therefore, y is 4. And then x plus 12, this is from the first row, plus 1 equals 15. So therefore, x equals 2. Now we can use our calculators to get a pretty quick answer for this. And what I'm going to do is I'm going to go into my matrix menu, and I'm going to put this matrix in to matrix A, and it's a 2 by 3. I'm not doing a square matrix. I'm putting in the augmented matrix here. Sorry, in this case it's a 3 by 4. So I'm just going to put in my matrix 1, 3, -1, 15. And be careful to make sure that you put the correct values in. If you put anything incorrectly, it's going to throw off your answer. I'm just putting in that original matrix. What we're going to do now is we're going to put this into what's called reduced row echelon form. And what that is, what it looks like anyways, is if we were to put this matrix and go further and go to reduced row echelon form, what we would end up with and then 3 values right there. So Z would be this one, Y would be that one, X would be the top one. So what I'm going to do now is I'm going to hit second, go back to my matrix menu, and under math, down towards the bottom, you see RREF. And then I'm going to take the reduced row echelon form of matrix A, or whatever I happen to call it, push enter. There's my reduced row echelon form. There's that line augmenting the matrix. So Z is -1, Y is 4, X is 2. It's a quick way to check your answer. You do need to become familiar with using these row operations by hand. Here are the problems that I would like to assign for these sections. The ones that have multiple parts, just do part A and B. That's what I'll be checking in class.